Alright guys, well welcome back. It's been a little while since we posted anything, but this is just going to be a math lesson. So for the couple of people that are waiting on investment advice, sorry, I don't really know when that's going to go up. I have it all recorded, I just don't know if I actually want to release it. And for those of you, like the one person that's waiting on my project's intro video, I'm really sorry. That's on a hiatus, to say the least. So this is just math. For the 4 or 5 of you or whatever that are waiting on other things, hopefully they'll come out. Alright, so operations radicals. A student sent me a couple of example problems that they would like me to work through. So I'm going to work through these. I think I'll post a follow-up video for this afterwards when I get some more free time, just to explain the steps required to get here. Okay, so I'm going to go ahead and work these problems, but it's going to require a lot of background knowledge. So we've got -2 times the square root of 294 m to the 16th. What is that? N to the 7th. Okay. So here's our first example problem, and what you're going to do is we're just going to work with everything that's under the radical. So let me highlight real quickly. We're only worried about the stuff underneath the radical, because this thing outside of it, whatever this is, whether or not it's -2 or -15 m to the 3rd z to the 50th, it doesn't matter. Anything outside the radical is already simplified because there are already things. Okay, so what we've got to deal with is all this stuff. And what you're going to do is you're just going to typically move from left to right, but it's going to be numbers and then your letters in alphabetical order. Okay? Numbers and then letters. You would technically need to simplify this if you can, but you'll notice that there's nothing in here I need to simplify. Alright, so what we're going to do is we're going to highlight each individual part of this. You'll notice you have one number, 294. You have 2 different letters, m to the 16th and n to the 7th. So I'm going to rewrite this just to separate all of these out in different colors so it stands out a little bit more to us. Okay, so it's really like a 3-part problem. So we've got -2 on the outside here, which I'm going to go ahead and just write in pen. We don't really have to worry about it, so I'm just going to stick it over to the left. Alright, and again, we've got our square root sign. And we've got 3 different parts of this problem that we're going to deal with. 294 is the number, and then each individual letter. And remember, in any given problem, my blue marker's dying. All right, here's a new blue marker. That's better. Okay, so in each of these problems, there could be a different number of these. If I had like M, N, O, P, Q, whatever, then I'd have like 7 parts in the problem or something like that. 6? I don't know, I didn't count that. In any case, what you're going to do is you're going to treat it like several little problems inside of each one. So let's start with the number. If you remember properly, to take the square root of a number, what you have to do is you have to make your little factor tree. Okay, so if we're doing this without a calculator, if we're simplifying by hand, we have to do this with a factor tree. And you just have to name some numbers that go into 294. And you could notice larger numbers. I think your teacher likes it when you find a perfect square that goes into this, which is perfectly fine. There's nothing wrong with that. In fact, that is the easier way. But let's say you don't notice, like you just don't know what goes into 294. Well, you know it's an even number, so the simplest thing is 2. If you have to, you can break it down from 2. Okay? That's okay. There's no problem with that whatsoever. 187. Is that right? That's not right. Sorry. 147. There you go. Okay, so 2 times 147 is 294. And we can actually break this down a little bit further. Okay, and one thing that I mentioned a while back is that as you're simplifying in these factor trees, every time you break something down, so I told you 294 is equal to 2 times 147 in this case. I broke it down, so I'm going to go ahead and get rid of it. I'm going to cross it out so I don't accidentally add it in later. So 147 I'm just about to break down. So let's find some numbers that go into 147. You'll notice it's not an even number, so 2 doesn't work. So we would test 3 next. 3 does go into this, by the way. 3 goes in for 49 times. And then some people will notice that 49 is a perfect square. But let's pretend you didn't, so let's go ahead and break that down as well. And remember, every time we break something down, we're going to go ahead and cross it out. And 49, hopefully you'll remember, is 7 times 7. So what we've got is a 2, 3, and 2 7s. If you guys remember, to break down a square root, what you had to do is find a pair of numbers that are the same. 2 and 3 aren't the same, but 7 and 7 are absolutely the same. So you can go ahead and pull out 1 7, so 1 for each pair. All right? And then back underneath the radical goes whatever you couldn't pull out. We couldn't pull out a 2 and a 3. So it's 2 and a 3. What is 2 times 3? Hopefully you'll remember that that is 6. So what you've really got is 7 root 6 to simplify just that part. Remember your 7's outside the radical, so is this negative 2. Our numbers outside we're just going to multiply together. 7 times negative 2 gives you that negative 14. So I'm going to go ahead and write that answer way down here. All right, and we're going to get back to this. This is going to be our final answer at the end. So at the end here, this is going to be our final answer. We'll get to that in a little bit, but we only finished the first part, so that only takes care of this green part here. That's step 1. Okay, we simplified, we found out what came out and what's going to stay in. Eventually there's going to be a square root of 6 somewhere over here, but you know you had to pull out that 7. Okay, so we pulled out that 7, multiplied it by what was already outside. Here's that negative 14. Let's move on. Let's go ahead and take our blue part, our m to the 16th. So the square root of m to the 16th. Remember, we're splitting this into 3 different problems. So the square root of the number, square root of the first letter, square root of the second letter. Okay, so square root of m to the 16th. There are a lot of different ways to look at this. I'm going to teach you the way that I like to do this. Hopefully you've learned this. I'm going to show you 2 ways, just in case you haven't learned it. But remember, a square root has like an invisible 2 out here. Okay, it's a little implied 2. You can change any radical into an exponent. What happens is that this is your base, so you have a base of m, and that base has an exponent. The exponent is whatever this number is under the radical goes on top, and whatever this number is outside of the radical goes on the bottom. Hopefully you'll recognize that 16 divided by 2 is 8. So you're just going to pull out an m to the 8th here. That's it. Just flat out. Okay? So there is going to be an m to the 8th down here, which I'm going to go ahead and write. But let's talk about the second way that we could have done this, just in case we don't remember how to change a radical into an exponent. Okay? Just in case. What you would do is you would technically do that same factor tree thing, square root of m to the 16th, and you would break this down. Okay, well, m to the 8th times m to the 8th. I kind of skipped ahead and made it too pretty. You could have noticed that these are the same. You could have pulled them out, or you could keep breaking it down. M to the 4th, m to the 4th, m to the 2nd, m to the 2nd, and you could keep going, and then you just had to pair things up. So here we had a pair of m to the 8th, so we get to pull it out. Okay, this goes a lot further and a lot more complex and whatnot if you wanted to break it down to m times m times m, but that really just means I'd have to write m 16 times, and A, I don't have room for that, B, I don't want to use another page, and C, that just takes too long. So I don't really care for this way personally. I much prefer to turn it into a fraction. So let me talk about this method real quickly. Remember, all you're doing is you're taking the base, whatever the letter or number is, putting it there, and then you're going to give it an exponent that looks like a fraction. The top part of that fraction, the numerator, or the top, is going to be whatever was under the radical. The bottom part of the fraction, or the denominator, is going to be over here on the left of the radical. You can kind of think of it as them switching positions. So 16 was below the square root, now it's going to be above the fraction bar. The 2 is going to go beneath. So it's kind of like they're swapping positions. Okay? So under the radical means on top of the fraction. Under the radical, on top of the fraction. All right, that's how we got that. Now let's talk about n to the 7th. We're going to use the same technique that I used here, but you're going to notice that this isn't as pretty a number. Let's go ahead and talk about that. The square root of n to the 7th. Okay, and remember, square root still has that little invisible 2. You're going to turn this into an exponential form. N to the, remember, under the radical means on top of the fraction. 7 over 2. 16 over 2 simplified to 8. Made life really simple, really easy, really pretty. 7 over 2. Hopefully you'll notice that doesn't simplify. It just doesn't simplify. But what you can do is you can turn this into almost a mixed number. Let me ask you this. How many times does 2 go into 7? Not evenly, but what is the maximum number of 2's you can get out of 7? Okay? Hopefully you'll think of this. So like 2 times 1 is 2. Yeah, that goes into 7, so it goes in 1 time. 2 times 2 is 4. That still goes into 7. 2 times 3 is 6. That still goes into 7. But 2 times 4 is 8, which doesn't go into 7. So 2 goes into 7 3 times. Okay? So what you've got is n to the third, because you could fit 3 2's in there. But what's left over? When you try to take... When you take 7 and divide by 2, you do get 3, okay? So 2 times 3 is 6. We subtract. What's your remainder here? That remainder is what goes back underneath the radical. N to the first power, or just n. You don't really have to write to the first power, but I'm going to anyway. Okay, let me run back through that a little bit more slowly. And again, I'm going to probably do a follow-up video that explains these smaller parts. This video kind of assumes you're comfortable with it or know it. If you don't, then I'm going to release that other one. But what you've got is the square root of n to the 7th. So again, what's underneath the radical goes on top of the fraction. That goes underneath. And then we just have to ask ourselves, how many times does 2 go into 7? It goes in 3 times. So we pull out 3 n's, or n cubed. Okay? And after we pull out 3 n's, we have to ask ourselves, what's left over? Well, 7 divided by 2, when you do the math, you're left with a remainder of 1. So it's just 1 n underneath the radical. Okay? So let's take all the things that were outside and put them outside. So we had our 7 and our negative 2. 7 times negative 2 is negative 14. We had our m. M to the 8th was outside of the radical. M to the 8th. We had our n to the 3rd. It's outside of the radical. So let's go ahead and write n to the 3rd. Now let's talk about, now that we've dealt with everything outside of the radical, let's talk about what's left over in the radical. From left to right. So over here, what was left in the radical? A 6. So you'll go ahead and write that 6. Then over here, what was left underneath the radical? You'll notice there is no square root here. Okay, it was just m to the 8th, so we don't have to worry about this. Now over here, was there anything left underneath the radical? Hopefully you'll notice that there is an n still left over. So your final answer with this problem is negative 14 m to the 8th n to the 3rd times the square root of 6n. Alright, so hopefully that made sense. You'll have to go back and rewind if it didn't. I'm aiming to keep this video sort of short, so like I said, I'm gonna probably release another video with more basic information on how this works in a little while. Alright, let's go ahead and run through another one of your problems. I see one that has just multiple different kinds of radicals in there. So I guess this one, if we had to name this section, it would be like operations with radicals with different indices. So operations, with different indexes or indices, different indices. That is not how you spell that. Indexes. There you go. Okay, so different indexes. And if you will remember, indexes are the little tiny number that floats next to the radical sign. Like in this example that you guys have, it looks like this. And I'm going to write these in 3 different parts. So the cubed root of 24 minus... I'm glad that most of these problems are in 3 parts because I only have 3 colors of markers right now, so this is actually working out really well. The 4th root of 112, and then plus the 3 times the, 4th root of 7. Okay. Cool. So we've got 3 different parts here. That green is a 4, by the way. And that's a cubed root. So I should probably have made that smaller here. Cubed root. Alright. So we're going to start from the far left and we're going to work this out. You're just simplifying each and every individual one. So to simplify any number underneath any radical, we're just going to make our factor tree. Again, you'd be looking for a triplet, so a perfect cube would be nice. You're not going to get one here, but it would still be nice to find. What you're going to do is, if you didn't notice, you're just going to break down with whatever numbers you can. Let's say you notice it's an even, so you can break down by 2. In this case, you could use 3, 4, 6, a lot of different numbers. Okay, so 2 times 12, and again, every time you finish using one, go ahead and cross it out. All right, break down the 12, 2 and 6, or you could use 3 and 4, doesn't really matter. And let's break down the 6, 2 and 3. Oh, sorry, wrong color. 2, 3. And we cut out that 6. And remember, what you're looking for is a group of 3 of the same number. 3 because our index here is 3. So we've got 1, 2, 3 2's. So we'll go ahead and pull out 1, 2. But what's left over is this 3. So it's 1, 2 cubed root of 3. Okay, so remember, the thing that you can't pull out goes back underneath your radical, and the index stays the same. In math, your indexes are never going to change. At least not in any math that you would see for the next like 4 years. The only time that indexes would change is when you're at a really high level math class, way beyond anything that I took. And honestly, it'd be theoretical. Okay, so your indexes are going to stay the same all the time. Now we'll go ahead and go on to the second part of this problem. Bring down our minus sign here. So our green problem, we're going to do the same thing. You know, honestly, I should have written this down below because some of these, like this one's probably going to take a couple more lines. So I'm just going to move my answer here down a couple of lines. 2 cubed root of 3. All right. So let's work out our green problem. 2 times the 4th root of 112. Remember, outside, we've got a number or something. We don't even worry about it. We're just worried about this. And again, it's a number, so let's go ahead and break it down. 112, let's pick 2 numbers to go into 112. We can just go with 2 because it's an even number. So this would be 56. And then we'd break down 56. Remember, every time you break something down, go ahead and cross it out just so that you remember not to use it anymore. 56, we'll break that down. It's going to be 2 times 28. And we'll go ahead and break that down. 2 times 14. And we'll actually break that down as well. 2 times 7. Okay? So all I'm doing is finding things that go into these numbers. Remember, this is a really simple process. Just use your calculator if you're not sure what numbers go in. Okay? And remember, you're looking for a group of 4 because your index is 4. So here's 1, 2, 3, 2, 4 2's. 1, 2, 2, 2, 3 2's, 4 2's. I skipped a number, but the point is there are 4 2's. Okay? So we cross them out and we get to pull 1 out. Let's pull 1, 2 out. Remember, there was already a 2 out here. So it looks like that. And then let's put our 4th root back. And what's left over is just that 7. Alright. This, let's go ahead and simplify. Hopefully you'll remember. 2 times 2 is 4. So this is really 4 times the 4th root of 7. Okay, let's go ahead, go one more. We've got our orange. Outside, we have a 3. And don't forget that when we get to this part over here, but it's just outside. We're not going to do anything at first. Here's our 7. Can we break down 7 at all? Hopefully you'll notice that 7's a prime number. You can't break it down. So this last part doesn't require any work because we can't do anything. So we're just going to tag it on at the end here. So plus 3 times the 4th root of 7. Okay, so you've got 2 cubed root of 3, 4 4th root of 7, 3 4th root of 7. Hopefully you were able to learn that you can add and subtract things that have similar radicals. They work almost like variables. So the 4th root of 7 and the 4th root of 7 are the same. So you can go ahead and add their coefficients, or the numbers in front of them. I had a 4 here and a 3 here. There's a plus sign. So this is like 4 plus 3, which is 7. And we'll just write this in, I guess, I don't know, orange. So you've got 7 times the fourth root of 7. In case that was confusing, radicals work under a similar operation as variables. So if this was confusing for you, rewrite the problem. Call it 4 times, instead of the fourth root of 7, let's call, anytime you see the fourth root of 7, let's call it x, plus 3 times, not the fourth root of 7, let's call it 3x. What happens when I add 3x and 4x? You would get 7x, which is the same reason why you get 7 times this mess here. Okay? And this would be the end of your problem. You're done. Reason you can't go any further is because this is not the fourth root of 7. It's a different thing. So this would be like a different letter. It would be kind of like saying 2, I don't know, y minus 7x. We can't combine these because they're not like terms. So because these two have different values, the cubed root of 3 and the fourth root of 7, it's almost like they're different variables and we can't combine because they are not like terms. Okay? Follows the same exact properties. So that's all you're doing. This follows up exactly with this. Okay? You just have to simplify it, get it down, and hopefully, normally if you're given a problem like this, 1, 2, maybe 3 of these will have the same radical value so that you can combine them. So over here we could combine these two, but we couldn't combine that, so we just write that as our final answer. So again, that's your final answer there. Okay? Cool. So feel free to rewind that. And then let's go ahead and hit another problem because I saw a couple of different types here. Let me see. Okay. So here is the other type that you were given. I don't know what I would call this. I guess FOIL with radicals is what I would call this. That's what I'm going to title this page, FOIL with radicals. So hopefully you guys remember how to FOIL. If you don't, well, actually I do have videos for that. If you don't remember how to FOIL, you should definitely learn, but hopefully you do. Here's the example I was given. Square root of 3 plus the square root of 6 in parentheses times 2 root 3 minus 5 root 6. Okay. That's what you were given. It's a FOIL problem, and we know it's a FOIL problem because I have two binomials sitting beneath, I'm sorry, not beneath, inside of parentheses, separated by their little plus and minus signs, you know. Okay, so these are two binomials separated by parentheses, and we're multiplying them. There's no operation in between here, so it must mean that we're multiplying. So remember FOIL, we've got to multiply our first, outer, inner, and last terms. So first term. So we're just going to multiply root 3 times 2 root 3. Actually, that might get confusing. Hopefully this all makes sense. So I'm just going to do it straight up mathematically. And then if that makes sense to you, ignore the second part of this. Okay? So let's take root 3 times 2 root 3. There's essentially an invisible 1 right here. So let's multiply the things on the outside. What's 1 times 2? You get 2. Root 3 times root 3, you'll get the square root of 9. Okay. Some of you might notice something about that, but we'll get to that in a little while. I'm just going to do all of my terms. So that was my first. Okay. Let's do our outer. So we took our root 3, we multiplied it by the first thing, take our root 3, multiply it by the second thing. I probably should have done that in another color. I'll do that in green. Okay. Unfortunately with FOIL, I'm going to have 4 different terms, but I'm going to color the outer and inner both in green just because. So we're doing the outer terms, square root of 3 times 5 root 6. Again, let's multiply the numbers on the outside or our coefficients. There's only a 1 here and a 5 here. 1 times 5 is just 5. And then remember you have a square root. Square root of 3 times the square root of 6. What's 3 times 6? You get 18. All right. Now let's go ahead and do our inner terms. So square root of 6 times 2 root 3. Remember again, there's a little invisible 1 there. So let's multiply the outer. I'm sorry, the coefficients. 1 times 2 Alright, so 1 times 2 is 2. And then square root of 6 times square root of 3, you'll also get 18 again. Alright, so that was the inner terms. Now let's go ahead and do our last terms. Alright, this one I'll do in orange. So our last terms are going to be 1 root 6 and negative 5 root 6. So when we take, oh, I'm so sorry. Oh, I messed this up. I could go back and edit this, but honestly I don't have time because I need to get back to work in about 20 minutes. So I'm just going to make a note. When I took the root 3 and multiplied it by the outer term, so this one here, I made a mistake. This is a positive square root of 3. That's a negative 5 root 6. So that means that my work here, this plus sign should be a, hopefully you'll notice, it's supposed to be a minus sign. Okay? So that's what happens when you're not paying attention. But again, I don't have time to edit this video, but I do want to get it up for you. So I'm just going to go ahead and just shove that minus sign in there. So that was because I missed a minus sign. So over here, we're going to actually use our minus sign. Okay, so our minus sign, I said I'd do this in orange, minus sign. Okay, and again, multiply your coefficients. 1 times 5 gives you 5. And then root 6 times root 6 gives you the square root of 36. Okay, you're almost done. In fact, you're pretty much done. You just have to simplify a couple of things. First off, let's talk about like terms. Are any of these radicals the same? Hopefully you'll notice that my 2 that I highlighted in green have the same exact radical, so we can combine these. Alright, so let's go ahead and bring out everything back down. 2 root 9 minus 5 root 36. We'll get to those in a second, but negative 5 plus 2 gives you a negative 3. Don't forget to carry your root 18. Alright, so we've combined those. Now we have to simplify. This should be pretty easy. What's the square root of 9? Hopefully you'll remember that the square root of 9 is 3, so this is the same as saying 2 times 3. Alright, what's 2 times 3? Good. Alright. Let's also talk about this last one just because it's really easy. What's the square root of 36? Hopefully you'll remember that the square root of 36 is 6. What's 5 times 6? Well, negative 5 times 6 gives you that negative 30. Alright. Now let's talk about the middle part. Minus 3 root 18. This one's a little harder because the square root of 18 isn't a pretty number, so we have to simplify a little bit. 9 times 2. And then 3 times 3. Remember, you're looking for pairs, so we get to pull out a 3. So negative 3 times 3 is a negative 9. Because remember, we pull out 1 3, but we already had a 3 outside here, so we got to multiply them together. Gives you that negative 9. And then you still have a 2 left in your radical. So don't forget, you didn't pull this out, so it needs to go back underneath this radical here. Okay? Now, do you see any like terms here? Obviously, this is the only one with a radical, but these two are just numbers. What is 6 minus 30? Hopefully you'll remember, or hopefully you'll be able to calculate. 6 minus 30 is a negative 24 minus 9 root 2. And you would call it quits there. That's really all you can do with this problem. There's not really anything else you can do unless you wanted to factor out a negative 1 or something like that. But that's pretty much the end of that problem. Okay, so let me get all of this on screen. This is just a FOIL problem. So you're just multiplying the first terms, outer, inner, and then last. Okay, so first, outer, inner, last. That's all you're doing. And hopefully you remember how to multiply radicals and that sort of thing. Again, all of these smaller techniques, if you don't remember how to do them, that's a whole different lesson, and you should definitely spend some time working on that. So for foiling with radicals, you do have to remember how to A, simplify radicals, B, multiply radicals, and C, add and subtract radicals. Okay, so all those things are important. Let me see if there are any other ones. Okay, so these other ones that were sent to me, how many were sent to me? 5? Did that one, did that one, did that one. I've already done 3. So there are, yeah, just 2 more. Okay, well, let me go ahead and do all these problems that were sent to me. just so they're here. This video is probably running longer than I expected. My numbers are doing fine, but I am going to have to get back to work soon. So I'm going to go ahead and run through these real quickly. Here's one of them. Let's see, what would I call this? I guess multiplying radicals. Didn't I already have a page like that though? Nope. Okay, I just had operations. So this is specifically multiplying with radicals. I'm going to shorten that to rads. Okay, so multiplying radicals. Here's the example given to me. Cubed root of 12, sorry, that's a negative 12, x to the 4th y times the cubed root of 4x squared y squared. I guess the one big rule that you have to know about these is that when you're multiplying radicals like this, make sure your indices are the same. So you'll notice that we have a cubed root of 3 and a cubed root of 3. So this is a-okay. If this were a cubed root of 5 or something like that, then this problem would be fairly different. It's not like it's impossible, just more complex. So because they're the same index like this, we can just multiply what's underneath them really easily. Okay, so what this becomes is that you're just going to take this and you're going to go, okay, well this is like the cubed root of both of these. Negative 12 x to the 4th y times 4x squared y squared. So here's the rule. Whenever you have two radicals with the same index and they're separated by a multiplication or a division sign, you're just going to multiply or divide whatever is underneath their radicals. Okay, so we're just going to multiply these two together. Let's go ahead and do that. Negative 12 times 4 gives you a negative 48. X to the 4th times x to the 2nd. Remember, when we multiply values with exponents, you're just going to add the exponents, so 4 plus 2. And then y times y to the, was that a 2 that I wrote? Yeah, it's a 2. Okay, it might be hard to see. That's a 2. Okay, so y to the 1st times y to the 2nd, that's 1 plus 2, gives you y to the 3rd. All right, and then now we're just going to break each individual part down. From this point on, it becomes exactly like the first example that we did back here. Okay, you separate it into multiple parts and you just break each of them down. I'm going to do that here, but I'm going to do it a little bit more quickly than I did on the last one. So 48 breaks down. Keep in mind it's a negative, so because we have a negative, I think your first step, honestly, is to get rid of the negative here and just go ahead and pull out your imaginary number immediately. All right, so let's break down 48. It's just a regular number. Remember, we're looking for groups of 3. I can already think of one that's very, very useful, but we'll break it down as if we were breaking down, you know, we weren't sure. So 2 times 24, 2 times 12, 2 times 6, 2 times 3. Okay, and we're looking for a triplet here. So we've got a triplet of 2's, so we get to pull out a 2. And 2 and 3 have to stay underneath. So this is going to be 6 underneath the radical. All right. I'm going to break down my x to the 6th. Remember, we can take our x to the 6th and we can write it as a fraction. So x to the 6 over 3, or x to the 2nd. And then over here we've got y to the 3rd over 3, so y to the 3 over 3. This actually works out really, really pretty. So at the very least there's that. That becomes y just to the 1st, or y. All right. So what you've got is 2 I x squared y to the 1st, or just y. And then underneath the radical, there are no letters, but there is this 2 times 3. So underneath the radical, please don't forget, you've still got root 6. If that was a little bit fast, go ahead and go back to the beginning of the video, because what I did here was exactly the same, just a little bit easier than what I did on this page here. Okay, so operation of radicals, that first page that I covered, is exactly the same as what I did here, just broken down more slowly. All right, and one last problem was sent to me. This one's essentially FOIL again, honestly. This one's pretty much FOIL. I'm going to go ahead and write it out. It looks like this. Square root of 5 minus 2 squared. A couple different ways you can go about it, but I would say that this is just a FOIL problem. Since you've already learned FOIL, let's go ahead and go with that technique. Remember, anytime you square a binomial, it's just it. Well, actually, when you square anything, but it's just it times itself. So if anything, this becomes really easy because it's just squaring this, and you're just going to do your first, outer, inner, last again. I'm not going to worry about any tips and tricks. It's just FOIL. Stick with what you know. If you notice some easy tricks and whatnot, they are probably applicable. This problem does get a little easier, but let's talk about just FOIL. So remember, you're going to take your first term times your first term. So first, square root of 5 times the square root of 5 is the square root of 25. Hopefully you know that the square root of 25 is 5. So whenever you take the square root, whenever you take a square root of something times itself, it's always going to equal that number or letter underneath. Okay? So like the square root of 3 times the square root of 3 is 3. Square root of 50 times the square root of 50 is 50. It's just whatever's underneath. All right? So let's talk about outer. Square root of 5 times negative 2 gives you negative 2 root 5. Negative 2 times the square root of 5 is negative 2 root 5. And then last is negative 2 times negative 2 is a plus 4. We can combine these because they have the same radical. So it's negative 2 minus 2. Negative 2 minus 2 is negative 4. Don't forget your radical, plus 4. Again, this came because this is the same as saying negative 2x minus 2x. So we can do this and we can just say, all right, well, negative 2 minus 2 is negative 4. But don't forget there's an x. In this case, x is root 5. Okay? It follows the same rules, just don't lose your radical. All right. And then 5 plus 4 gives you 9 minus 4 root 5. All right. So this problem is just a FOIL problem. It's exactly the same as the thing I did, what, 3 problems ago? Nope. 2 problems ago. There you go. Same exact thing as that. So again, if you were thrown off by any of this, you'll have to refer to these other ones. I know I went through this last one, or these last 2 rather quickly, but they're pretty much exactly the same as some of the other stuff that you've already done. They're fairly easy. So really, if you can get these first couple, this first one here, operation with radicals, the operation with different indices, and then I guess this one, but this one's essentially the same as the first one. You've got pretty much everything you need. Okay, so these first 3 are probably the most important. These last 2 are exactly the same as some of the other ones. They're just quicker. So I would definitely go back and check those out. I will release a backup video with more background information, but I had to get back to work. So hopefully this helps. Feel free to text me or call me or whatever. If it doesn't, I'll probably be working, but hopefully I'll have the follow-up video posted tonight, if not by morning before everybody starts their day and I end my day. All right, so have a good night. Best of luck. And again, I'm so sorry to the people that were hoping this was a different video. Investment project updates coming eventually for like the 4 or 5 that care. All right, guys, take care and best of luck. Bye.